In this unit, we start talking about continuous data. Now, if you remember the difference between continuous and discrete data, continuous data can be a decimal. So continuous data is things like volume, height, weight, temperature, things that can have a decimal. And it's helpful to remember that continuous data could take an infinite number of, we can take it to an infinite level of accuracy. For example, if we're talking about temperature, we could say that it is 25 degrees Celsius outside. Okay? If we have a very accurate thermometer, we could take it to a greater level of accuracy. We could say it's 25.24873 and so on degrees Celsius outside. So for that reason, when we're talking about continuous data, we don't talk about the probability of one data point. Okay, we're going to talk about the probability of values being greater than a specific point, less than a specific point, or between 2 points. Because we can think of continuous data as being a bit slippery. It's hard to nail it down to one exact value because it can be decimals, which means it can be increasingly accurate, increasingly specific. Okay? So the normal probability distribution is one of the most famous distributions in all of statistics. And as we're going to learn later in the course, if we take any continuous data pool and we take a truly random sample and our sample is big enough, the sample will form what is called a normal distribution. Okay, and we need to know the characteristics of the normal distribution. Now, something about the normal distribution that sometimes confuses students, okay, when we draw a normal distribution curve, okay, we start off, we draw the axis, okay, the x-axis. Now, something that confuses students, students are used to having an x-axis and a y-axis. Yes, this is the x-axis, this is the y-axis. Now, if you look at these diagrams of the continuous distribution, of the normal distribution, you'll see that they've just drawn x-axes. Okay, that's normal. That's the way it's done with the normal distribution because, as I mentioned earlier, we're not interested in probability of a specific point. Okay, we're interested in the probability that something can be greater than, less than, or between some values. So the normal distribution, this line is just a normal x-axis. Okay, the y-axis exists, we just don't usually, we never put it when we're talking about normal distributions. So you are responsible for knowing these 6 characteristics. Okay, now the first characteristic of the normal distribution, well, let's go through them in a more logical way. Okay, every normal distribution, it's shaped like a bell and it's centered over the data pool's average. Okay, so when we draw a normal distribution, we draw the x-axis and then we make a dotted line, okay, and the dotted line represents, oh, that's a very messy looking mu. The dotted line represents the average of the data pool. Okay, so then after we draw the dotted line, then we draw the curve. Okay, so the normal distribution, it's shaped like a bell or a mountain and it's centered over the mean. Okay, and we remember from previous units that mu is our variable that represents the mean. Okay, the total area under the curve is 100%. Okay, this area under this curve is equal to 100%. The curve is symmetrical. Okay, let's look back at our PowerPoint. The curve is symmetrical. Okay, that means it's like a mirror image. Let's enlarge this slide a little bit. It's like a mirror image. So this half of the curve is an exact mirror image of this half of the curve. Okay, and since the total area under the curve is 1, we know that 50% of that is here, 50% is here. Okay. Now you'll notice that the tails, they don't touch the x-axis. That's the characteristic of being asymptotic. The curve gets closer and closer to the x-axis, but it never actually touches it. It's kind of a strange characteristic to think about, but we just have to accept it. Our purpose is not to debate these characteristics. The normal distribution, as I mentioned earlier, it's centered over the mean, so the location is determined by the mean. The mean, median, and mode are always equal. That's another strange characteristic. We just have to accept it. Let's go back to characteristic 4, and we're going to talk about that a little bit. Okay, the dispersion of a normal distribution is determined by the standard deviation. So let's go down and let's look at this. Okay, I will draw 2 normal distributions. Okay, so here's one. Let's say these are that in exam 1. Okay, let's say that this is class BUO1. Okay, in the first exam, the average score of BUO1 was 78%. Why did it change the 7? And the standard deviation was 3.1. Okay, so the average score for one of my classes on the first exam was 78, and the standard deviation was 3.1. Now, let's say that my class BUO2, their average in that class, so they took the same test, and that class, the average of all those students in BUO2 was also 78%. Okay? Now, actually I want to change the size of this. Okay. Yes. Okay. So both classes had the same average on the exam. BUO1 had a standard deviation of 3.1. However, BUO2 had a standard deviation of, let's say they had a standard deviation of 6.7. Now, the difference in standard deviation, it's reflected in the fatness of the curve, and that's why I had to go back and redraw this one. Okay? So the general rule is the taller and thinner the curve, that means it has a smaller standard deviation. The shorter and fatter the curve, the bigger the standard deviation. Okay? So if we look back at our PowerPoint, we'll see here. This part of the PowerPoint is designed to show you the difference in the curve shape and width, yeah, with the different standard deviation. These 3 distributions, the blue, green, and red, have the same mean, okay, but we can see that the red one has the smallest standard deviation. That's why it's the tallest and the thinnest. The green one, the standard deviation goes to 3.9, so it's a bit shorter and a bit fatter. The blue one has the biggest standard deviation, so it is the shortest and fattest. So that's what this part means. The dispersion or spread of the distribution is determined by the standard deviation. Okay, excuse me. You are expected to know these characteristics, and if you've been attending class and paying attention, you will realize that we've been reviewing these characteristics at the beginning of every class. Okay? If you don't know them, you need to learn them by yourself.